Now, did you hear that? That was me breathing in for dramatic effect. I'm recording this podcast from my classroom. I normally record my podcasts at home where I've got a proper microphone. But anyway, I thought I'd record them in my classroom. So it might sound a bit different to the normal podcast. So forgive me. But anyway, back to the subject in hand. And today I thought we'd talk about, because we did before the fart episode, which I thought was brilliant, by the way. Before the fart episode, we looked at the heart and the blood and the function of the heart and the blood. And as part of that, and linking in very nicely, thank you very much indeed, is this next bit all about breathing and gas exchange. So, hopefully you, whilst you've been listening, have been breathing too, because if you haven't, we've got problems and you'd be dead. But anyway, it's good that you're breathing. And did you also know that you do this breathing thing around 20,000 times a day? And you don't have to think about it, do you? And when we talked about hearts and blood, that's another thing that your body just does, and you just don't have to think about it. And it's just magic, really, isn't it? Anyway, welcome to episode 6, which is another brilliant episode. I'm Simon the Science Guy, head of science here at Bankside School, and I hope you've enjoyed the podcast so far. And I thought we'd focus in, as I said, on breathing. So, where does this air go that we breathe in? Where does the air go? So, it goes through your nose or your mouth. And did you know your nose is a better fit for this? Because when you breathe in, you should be breathing in through your nose because it traps the dust and germs before they get any further. All those little hairs in your nose are filters and they act as part of your body's defense system. So try breathing in through your nose rather than your mouth. Anyway, where does it go once you've breathed it in? So it then travels down your throat into the tube in your neck. And that tube in your neck, of course, is your trachea or your windpipe. And you can feel that tube if you gently press the front of your throat. And your trachea splits into two. And as it splits into two, one bit goes into each lung. And those branches that go into each lung are called your bronchi, B-R-O-N-C-H-I, bronchi. And they split into smaller and smaller and smaller tubes in your lungs. And they're a bit like branches of a tree. They get really spindly and thin. And right at the very end of those spindly thin branches are little air sacs, tiny bubbles, hundreds of millions of them. And that is where the magic happens. And they are called alveoli, A-L-V-E-O-L-I, alveoli. But how does the air actually get in? Your lungs can't pull it in on their own, they need help. So, underneath your lungs is a big flat muscle called the diaphragm. And when you breathe in, your diaphragm pulls downward. Your rib cage lifts up and out. That makes more space inside your chest. And because there's more space, air rushes in. And when you breathe out, your diaphragm relaxes back up, your rib cage drops, and the space gets smaller, and the air gets pushed back out. And that's it. That's like breathing. But let's go back to the alveoli bit, because you've got roughly 300 million of them in your lungs, and each one's tiny, smaller than a full stop on a page. But together, they add up to a massive surface area the size of half a tennis court. Half a tennis court, all folded up inside your chest. But why does that matter? Because your body needs to swap two gases, remember? It needs to take out the oxygen from the air that you've breathed in and get rid of the carbon dioxide, which, as you all know, is the waste gas that your cells produce. And here's how the swap works. The air that you've just breathed in has lots of oxygen in it, anything from 20 to 30 to 40%. The blood that's been around your body is low in oxygen because your cells have used it up. So the oxygen moves from the alveoli, where there's loads of it, across into the blood where there's less. And at the same time, your blood has picked up the carbon dioxide from your cells, and there's lots in the blood, but not much in the air sacs. So the carbon dioxide moves the other way, out of the blood and into the alveoli. So then you breathe it out. It's like a perfect swap. This movement from where there's lots of something to where there's less has a name. And it's a brilliant name, and it's called diffusion. So think of it like this. Imagine someone sprays perfume at the end of the room. The smell spreads out. It moves from where there's lots of it, near the spray, to where there's less of it, to the rest of the room. No one pushes it. It just spreads on its own, right? That's diffusion. Your lungs are using the exact same principle in every single breath. So your alveoli are doing a tremendous job. But why are they so good at it? And there's four main reasons. One, there are loads of them, hundreds of millions. So more surface means more swapping can happen at the same time. Two, the walls are incredibly thin, just one cell thick. That means oxygen barely has to travel any distance to get into the blood. The thinner the wall, the faster the swap. Three, they're surrounded by tiny blood vessels, and the blood is always moving through, carrying oxygen away and bringing more carbon dioxide in. That keeps the swap happening continuously and constantly. Number four, they're lovely and moist inside, and gases dissolve into the moisture first, which actually helps them cross into the blood more easily because they become a liquid. So actually, it's just fantastic. You've got an amazing system in your lungs, good blood supply, moist lining. It's just four bits of magic that happen. So, have you ever held your breath? So after about 40 seconds, you get desperate and you need to breathe. That horrible feeling isn't your body running out of oxygen, not yet anyway. It's the carbon dioxide building up in your blood, and your brain detects it. Your brain panics a bit and basically shouts, breathe, now, you must breathe. So what about yawning then? Nobody fully agrees on why we yawn, by the way, and the science about yawning is a bit weird. But one idea is it's a way of taking in a big gulp of air quickly that might cool the brain down when you're tired. And so it might be a way of staying alert. So nobody really knows what yawning does or why we do it. It's a bit of a quirk. What we do know is that yawning is absolutely contagious. Even reading the word yawn can set a yawn off. Um, Now, what about a stitch? Have you ever been running and had a stitch? Now, that's probably your diaphragm cramping. Remember, that diaphragm is that big flat muscle. And when you run fast, your breathing speeds up. It's bound to speed up, isn't it? Your diaphragm is working hard. And if it's not getting enough oxygen rich blood, it protests. It shouts out, oi! So slowing down and taking deep breaths usually always helps because it gives the diaphragm a chance to recover. So, before we finish, 5 words that I'm going to leave you with. The first word, trachea, or trachea, as our American friends say, and that's your windpipe. That's the tube that takes air from your throat down to your lungs. Alveoli. Those are the tiny little air sacs, remember, where the gas swap happens, carbon dioxide and oxygen. Diffusion. When something moves from where there's lots of it to where there's less, no energy needed, what we call passive. The diaphragm. That's that big flat muscle under your lungs that pulls down to let air in. And finally, gas exchange. The swap of oxygen into blood and carbon dioxide out. So that's breathing. That's literally breathing. One big breath through your nose, down your trachea, into your lungs, all the way into your alveoli, where the oxygen swaps into the blood and the carbon dioxide swaps out. And it happens roughly 15 times a minute, every minute, all day, whilst you're sleeping, whilst you're watching TV, whilst you're on your iPad, whilst you're doing everything. And in fact, whilst you've been listening to this. And this connects everything we've done in the series so far. We've talked about the heart in episode 5. It's the heart that pumps the blood around the body. And in episode 4, we talked about energy and the cells that oxygen needs to release energy from our blood. And these are all working together. Breathing, blood, energy, one system. So, in our next episode, ladies and gentle frogs, we are going to be looking at germs. So what is a germ? See you then. Have fun, science guys.